Okay, so then now let's talk about the other part of this formula, stroke volume. So we probably are running out. We are running over time. If you have your lab right now, don't worry, this stuff will be up later. But if you can stick along, I'm just going to start to record the stroke volume part of this because you need both heart rate and stroke volume to calculate cardiac output. So stroke volume, this is the amount of blood pumped by each ventricle per contraction. So how do you, and let's talk about just cardiac volume. So stroke volume, when your heart beats, basically how much blood is it squeezing out with every beat? That's what your stroke volume is. Or actually not your heart in general, just one ventricle. When a ventricle contracts, how much blood is being squirted out? That's your stroke volume. Now the end diastolic volume, what is that? So this is the amount of blood in the ventricles at the end of atrial systole. And again, this is why you need to know systole and diastole. So, or actually, not at the end of atrial systole, it should be diastole. I made a mistake there. So amount of blood in the ventricles at the end of atrial systole. Oh, wait, actually that is right, it is right. Sorry, it is atrial systole. So atrial systole is going to fill the ventricles, but what more is like end diastolic volume, ventricles are relaxed, they're fully filled. So this is the volume in your ventricles when it's fully filled. And sometimes it's interchangeably used with this term called preload. Now, preload actually refers to the amount of stretch in the cardiomyocytes and what we call sarcomeric length. And if you were here last semester, you might remember what sarcomeres are. So basically, the more you fill, basically, how much did you fill the ventricles with? The ventricles are relaxed. What's the maximum volume they are at when they're fully relaxed? Now, what we have here is end systolic volume. So systole is when it's going to squeeze, and now it's going to talk about the amount of blood left in the ventricles after you've squeezed it. So the thing about your ventricles, when they squeeze and do systole, they don't collapse flat. They actually they constrict, but they don't squeeze every last drop out of your heart. So there is some blood left over. So why do I bring up these two volumes? This is how you calculate your stroke volume. Okay, the max volume when it's fully filled and relaxed after diastole in the ventricles, and then systole. So that difference between the max diastolic, the end diastolic volume, and the end systolic volume, that is your stroke volume. So because when the ventricles contract, that blood has to go somewhere, right? So that's going to go through your aorta or pulmonary trunk, depending if it's the left or right. So to show it more visually, so again, end diastolic volume, that's the volume in a ventricle when it's fully relaxed. End systolic volume, that's the amount of blood left after the ventricle has completely squeezed. And stroke volume, that's the difference between the two. So again, end diastolic volume minus end systolic volume equals stroke volume. So here we have our relaxed ventricles, and here we have the contracted ventricles. Let's look at the left ventricle only in this example. So again, this is our left ventricle end diastolic volume. Here's our left ventricle end systolic volume. So the difference between this and this, that is our stroke volume. So that difference in volume between that. So that's how you're able to calculate your cardiac output. You multiply your heart rate by stroke volume. Now, why do I bring this up? There's yet another measure of cardiac function called ejection fractures. And actually, I'm going to release the survey right now. So I have the survey about like the calculators, but this is why I'm kind of like showing you the math now so you know what's involved. So what we have here is that end diastolic volume is the volume after relaxing, and stroke volume. So ejection fraction. So you actually need to use both of these volumes to calculate a measure of cardiac function we call ejection fraction. So what you do is take your stroke volume, divide it by your end diastolic volume, and then convert it to a percentage. So basically, of the blood you fill the ventricle with, how much of it did you actually squeeze out from that ventricle? That is your ejection fraction in your heart. So that's one way cardiologists evaluate how well your heart is functioning. So these are definitely the 4 parameters of cardiac function I want you to know in terms of volumes. And then how do you measure all of these? So you use a different thing. So don't confuse this as an ECG. Usually when you refer to echocardiograms, one, they're not the same thing as electrocardiogram, even though it sounds similar. But this is what we see with a transthoracic echocardiogram, or TTE. So what we see is actually you have like this ultrasound probe, and you're actually looking at the heart and the chambers. You see actually the valves, and you see the chambers contracting. So there's complex software. I don't know what the software is, but they're actually able to measure the volumes and get these volumes without actually having to cut someone open. So all you do is put a probe there, and then you're able to measure the volumes of the ventricles when they're fully relaxed and when they're fully contracted. And that's how you can calculate stroke volume, just by doing this non-invasive or relatively non-invasive procedure.